we can go ahead and get started. And just moving on to our next topic, kind of sticking with our originally planned schedule. Our next topic is scanning and enumeration. And I try to somewhat demystify some of the terms I'm using just to kind of describe these technical topics and milestones. Scanning, we will learn quite a bit about in this particular topic. Now that we have some knowledge about what hosts are potentially relevant for the organization or network we're interested in, what more can we learn about them? Enumeration is also directly related to scanning. Enumeration just means assigning a number to something or keeping a count of a certain number of things. So we're trying to determine from really the starter information we have from our reconnaissance tasks, a little bit of investigative work that you did as part of also Lab 1, we have a little bit of starting information, we have domains, we may have some IP addresses, we may have some contact information and net IDs and things of that nature. What else can we learn from there? Can we do so in a relatively stealthy manner, and can we really explore the underlying network architecture, at least what is available in a public-facing way? We are still on our steady state schedule. You could argue that Lab 2 is the first quote-unquote real lab this semester. It's also going to be much more similar looking to the remainder of your labs than that Lab 1 experience. And again, we have another micro quiz this Thursday in class. So going back to our hacking methodology, we're really on that second step now. So we've done a little bit of that reconnaissance and footprinting. Again, in class, really just talk about the top level concepts. You do a little bit more of it in practice, and then in the lab environment, then in practice, it really depends on your particular topic. Next, our goal is to determine for a given network, first off, we have to do host discovery. What machines are actually running or what hosts are actually up and running in a given network? That is sort of the next intermediate step. Once we have some determination of what hosts are actually relevant to us, which ones are actually up and running in a given network, to the extent we can determine that, after that we then can determine things about those machines. Can we start to enumerate what ports are open and closed on those particular machines? From that information, can we then next determine what services those machines might be running? And then even beyond that, we can also start to determine versions of those services, as well as potentially what operating system is running on the particular machine. None of these techniques are entirely foolproof, and a lot of them actually just make use of known published signatures or even in some sense statistical information to give us a feel for what is running underneath the hood on those particular machines. But the general approach and the general goal is to learn more about each device. So we are still in a planning stage here. We are not doing anything that involves attempting yet to gain access to any of those individual machines. Although as we'll see, some of the tools can be kind of used in concert with the next step of tools to gain access to those machines. We're learning more about the machines. In our reconnaissance phase, we were really focusing on what sort of public-facing information is out there that we can explore about an organization to learn things about domains, hosts, IP address or IP address ranges. Now, given that information, we're going to go from that and determine, okay, we know that there's a potential range of IPs that are potentially valid for a given organization. Which ones are actually valid to the extent we can discover that, and what is running on those particular machines. Then we're going to go from there to determine, okay, if we know what's running on this particular machine, is it potentially vulnerable? And if so, how can one take advantage of it? So it's still a planning stage, but now it's a little bit more active than the prior stage. Prior stage was really just Google in a sense, right? We were looking at publicly available information and how to find things that either are intentionally made public or maybe inadvertently made public by an organization. And now we're relying more on technical skill set to learn more about the particular network here. And I want to add that as we are learning about different tools and techniques here, your goal, I think, as someone studying cybersecurity, and certainly those of you hoping for a degree in this area, should be more than just determining what are the tools and how do I use them. That's a really good starting point. And I would say in the lab, we wind up doing a lot of that. Okay, here's a network mapping tool. How do we use it? What are the different options? What does it mean? I think in class, a better use of our time together would be an attempt to really understand underneath the hood what is happening here. Because certainly those of you who have more of an engineering background, computer science background, software engineering background, those of you in cybersecurity engineering should be able to go underneath the hood and really determine, okay, this isn't just a magical tool that gives us, for this input, gives us this output. What is it actually doing? how do we relate that to what we've been learning in some of our other classes as well? And finally, the other quick note that I add here is that there isn't a single prescriptive approach, and you can kind of fall into a trap that way, that if you're just reading how-to guides, you'll learn a lot that way for how to approach a particular problem or a solution space that works for a particular type of organization and network architecture, but there isn't really one size fits all approach. It is not an exact science doing network mapping. It may seem like it should be, that there's computers and there's network and there's open sockets and we can just connect to them, but outside kind of inauthentic, artificial classroom type environments, it's not going to be straightforward as point this machine at this location and get back this result. So the needle in a haystack analogy isn't quite right, because we are not blindly searching here. We are starting with things like looking at DNS entries, who is records, or doing NS lookup, looking at some aspect of the organization. We're not just starting with the first possible IP address and iterating all the way through the last IP address. So while we're not blindly searching, for some of these tools and approaches that we're going to look at, there is an explicit trade-off between how complete our search can be versus how stealthy our search can be. And I do think that as you look at other resources, maybe those provided outside of this class's environment, and you look at ways to do things like network scanning, you really have to be a little bit careful, because oftentimes those resources are going to focus on, here's how you're guaranteed to get this result back out. But depending on what your goal is, you may be willing to make that trade-off of not just completeness and stealthiness, but also speed and stealthiness. I'm going to allow this scan to take quite a bit longer than potentially it could, in the hope that it's less likely to be detected at a firewall or intrusion detection system. And then similarly, I'm not going to enumerate every single possibility for fear of the same issue of being discovered by applying a complete port scan here. And also for that reason, our focus is primarily going to be on IPv4 versus v6. And there's a couple reasons for that. Can anyone suggest one of the reasons why, and most of these guides, resources would focus on IPv4 versus v6? Anyone have any thoughts? A couple of reasons why we would focus on one person. It is still more commonly used than IPv6. There was a time where this class, perhaps 15 years ago, I would have said, well, IPv6 is the future. We're silly for looking at IPv4. And that turned out to not necessarily be the case. There's another, that's one of the reasons. There's another reason why we may not necessarily want to look at IPv6. Sure. We could have done well, the way we set it up, it doesn't. We could have set up an IPv6 version of the labs. But there's also, it's a similar reason why we don't. Sure. Not necessarily, because the kind of things that were added to IPv6 are also essentially backported and provided in IPv4. The other point I was getting at for this needle and haystack analogy is one of the whole reasons for IPv6 is to greatly expand the IP space available, and going from 32 to 64 and more beyond bits for your IP address space is a huge increase in the number of targets one would have to search for. And for that reason, IPv6 isn't very pleasant to work with, right? It's all hexadecimal codes referring to the different address ranges, and even very simple things, but just unfortunately become a lot more complicated when dealing with IPv6. So most of these guides do. It's not just us, but our focus will be on IPv6 or IPv4, excuse me. So needle and haystack analogy isn't quite right, but it is kind of a detective type of approach. So I want us to sort of channel whatever famous inspector today or detective is your favorite. But then I put this together and I was worried afterwards that I'm old, you were relatively young. I'm not sure how many of these detectives you may or may not know. And in an effort to get you awake today, I'd like to hear some suggestions. Who do we recognize here? I'm up for suggestions. You don't have to raise your hand. You can just shout it out. Sherlock Holmes, thank you. Specifically BBC Sherlock Holmes. It's a pretty good version. Scooby-Doo and the Gang. I think they count as detectives. They're solving mysteries. That's a type of detective. Any others? That is Inspector Gadget. Yes. Who? Inspector, detective. I think it means the same thing effectively. That's great. Any others? Yes. Benoit Blanc. Okay, there we go. Others? Yeah, I was worried a bit about this. There was a time when the upper left corner picture would have been extremely well known. Agent Mulder and Scully from X-Files. What else do we have here? Jessica Fletcher from Murder, She Wrote. Okay, this is a dated concept here. Jean Valjean, Inspector Valjean from Les Mis. We're not very cultured here. That's okay. There's different levels of culture. Yes, that is Columbo. And so as we cover this, occasionally I'll say, "Oh, one more thing," and I think that's everybody. And then a version of Inspector Clouseau from the Pink Panther. So if you Google famous inspectors, I'm sure you'll get a very similar list, but famous is a relative term. We got about half of them, that's not too bad. So pick your favorite. If it's not one of those, that's fine as well, and we're gonna be kind of channeling this. Again, the risk or sometimes the error we make is in assuming that this is a how-to guide and that here's the approach we use to determine hosts and determine things like what ports are open. You can get pretty far with just sort of defaults, but I think we have the capability to kind of dig a little bit deeper and really understand what is happening underneath the hood. Why do certain things work? Why do certain things, other things not work? And as well as that trade-off between potential performance, speed, completeness of a scan versus a stealthiness of a scan here. And the first approach, the first thing we start with when we're trying to do host discovery, again, that's a quasi-technical term for determining, given an IP address range, domain, what hosts are up, what machines are actually up and available. That is not as straightforward as a problem as it may seem at first glance. Certainly by design, by direct intention, the whole idea of the ping, of Internet Controlled Message Protocol, ICMP, otherwise known as ping, was designed for that exact purpose. It is a protocol on top of IP that is explicitly designed to allow us to check, are you up or not? Host, are you up or are you not up? Determine if that host is responsive and alive. The other term you'll hear is a ping sweep, which is applying a ping, not just to a single IP address, but to a potentially large range of IP addresses. The ping command can provide us with, beyond just the information of whether a given host is up or not, it can also return things like different domain names that respond back, as well as the resulting IP address, as well as things like round trip indicators for how long that particular ping request took to return back. I think we've all done ping before, but in practice, we ping iowastate.edu. I say I'm just going to send 2 ping, count of 2 is that command line option, and there you get your result back out. So it's kind of doing an NS lookup for us as well, and it's letting us know that we sent these packets of data, we got this response back up. From this, your conclusion should be www.iowastate.edu is up, is available, is, in this case, a valid IP address for us to access. We know from experience that is not always the case. Breaking down a little bit what's happening underneath the hood, this is again probably a little bit of 230, 2300 review here, but as part of our IP packet structure, there's a lot that's the same with any other IP packet we may be sending, but we have that protocol field for which if you look at the different values of IP protocol, we're really using very few of the potential values here, but one of the values, if we set protocol equal to 1 in that field, that is corresponding to an ICMP packet, and then from within that, in the actual data field, in our payload of the IP packet, you would then have an ICMP header and corresponding data for that as well. So it is as this kind of abstracted, layered packet view of things. You have your IP packet, you have your ICMP codes on top of it, of which there are multiple different types that we can specify for an ICMP for slightly different purposes. The most common one we use, the one that I just used right now, is we put in a type 8 echo request. The machine, if it is following a spec, is supposed to respond back with a 0. You requested an echo, you got an echo back out. Also on top of that, you can request, here's a timestamp request, give me a timestamp response. That is what tools like traceroute can use to allow us to determine how long it takes to get to a particular location. That is a built-in ping application. There are all sorts of other applications that are great for doing ping. Angry IP Scanner, HPing. There's quite a few others, and they're all configurable to use various ICMP features to ping in different ways. I wanted to open up one of those quickly, so this was just the link that's provided there for the Angry IP Scanner. I think it's just called IP Scan. I don't recall why it's called Angry. There's nothing particularly angry about it. And it's written in Java, which I thought was interesting. We have some Java experience in the class. It's not requirement, but most of you should have had at least one Java class before. And as I looked at that, I was wondering, well, I know how to do this in a lot of different languages, but I actually don't know how to do this in Java. So I wanted to look at it. And again, we talk about going underneath the hood. It's one thing to have, a diagram of what that package should look like. It's something else entirely to say, okay, what does that mean in practice? And while we don't have the bandwidth to be true experts in a lot of different utilities, you do have the skill set to, instead of just blindly downloading a tool and trying it out, also taking a look at it and determining, okay, what is it actually doing underneath the hood? You can just connect to it on GitHub. I clicked this morning and looked at what was the actual ping.java. This is a little hard to read. Let's see if I can zoom in a little bit here. What ping.java happens to look like, because as I thought about it, I realized I don't actually know how to do that. So we look at this, we can figure out how to do it. And you scroll down, this is the Windows pinger. Depending on if it's v4 versus v6, you do call ping 6 versus ping 4. And if we look at ping 4, I was kind of interested in who is actually calling the ping, and basically not Java. So dll.icmp send echo, so it's calling a dynamically linked library. It's calling some other piece of code to actually do the ping itself. So all of this entire application is just really a wrapper on top of built-in ping utilities. If you look at the code for what DLL it's calling, it's the Windows ping call. So I was wondering how you do a ping in Java, and at least for this utility, you don't. You wrap it around, and you're actually just calling a built-in DLL, built-in Windows API in this case, that is very C++ to perform that particular ping. It's kind of neither here nor there, just an aside that we do have the skill set to dig a little deeper. Okay, here's a Java ping, here's a C++ ping. How are they different? What do they do similarly? And we should be able to, while not becoming true experts in the code base, we should be capable of kind of quickly looking at it and determining what is it actually trying to do under the hood. Now, while it's not necessarily considered best in class in all ways, I'd say for most of our scanning purposes, one utility checks nearly every box, and that is Nmap. So just a show of hands, how many of you are familiar with Nmap already? It's half-ish or half not following the question. And I think the height of which you raised your hand also kind of gives me an answer there as well. Nmap is ubiquitous in computer security work. There are other network mappers out there. There's other tools that can do scans. You have to be a little bit skeptical when you read certain claims about like this scanner is better than that other scanner. We talked about that trade-off space between the performance of a scan, how long it takes to do a scan, versus the completeness of a scan, versus the stealthiness of a scan. And at least in my own inspection of various quote unquote competing tools in this space, they're really just giving you different knobs to explore different aspects of that design space. There's not, at least to me, there's not clearly one that is far superior than another in any one dimension or another. There could be an argument made, potentially, that if one network mapper is that much more ubiquitous than others, that itself is a weakness in the tool. That as intrusion detection systems are designed, and the kind of things we'll be talking about here, will tend to get pretty precise in terms of what type of network signatures they're looking for, that if you have one tool that has a very common type of network signature that lots of people are using, that could be seen as a drawback of that tool. That everybody's using it, everybody has these kind of network signatures in their scans, and consequently they're easier to detect from this particular tool than another. So that's a valid argument, but I think it's still pretty much for our purposes, it checks every box is the term I use. I did not say that it was the best tool potentially here. It also is a tool that has very many command line options, as well as some compile time options as well. And we will have to become pretty familiar with the documentation of it throughout this semester. I have the link here, I have it open here as well. The trade-off is whether or not we need to memorize the documentation or whether we just need to know where to look for the documentation. My hope is, after you look at a particular piece of documentation n times where n is sufficiently large, you'll have effectively memorized it, versus me telling you, you must look at this command line and tell me exactly what -PE does. Either approach is valid, I think. You could sit down, memorize the entire cheat sheet for every command line option, or my hope is we get enough experience in doing it that you can look at it and determine exactly what that particular command line flag is doing. They're not obvious. In this case, -PE stands for ping using echo. So it's the exact same ping we just talked about. So ping this IP address starting at this particular start point to .1 through .254. Where it gets a little weird is that looks like it's a command to ping a host, but then we're getting reports back out about which ports are up. It's because Nmap is generally a port scanner first and foremost. So unless you tell it not to scan any ports, it's going to follow a default algorithm for also scanning ports for those particular hosts. But as another tool for performing a ping sweep, it is a pretty good example of a tool to use. And the other argument in favor of it is it's good enough for Trinity and characters in many, many other movies. Then it's good enough for me. That link is provided there. I have to be a little careful and not scroll all the way down in this link in class, but you get a feel for some of the movies that have famously used Nmap. Oftentimes, these pictures are a little misleading because what it is a very, very small window somewhere on a screen that shows that Nmap is working. So it's ubiquitous in Hollywood at least. So there's Trinity in The Matrix Reloaded using it. Ocean's 8, they use Nmap, at least it's kind of shown in the background. There's a movie where they use Nmap to SSH and to launch a nuclear warhead. So it's a tool that you see. So that is more tongue-in-cheek, but my thought is if it's good enough for The Matrix, it's probably good enough for me. And that's what you'll also be doing this week, starting today in lab. You should now have access to more than just your Kali box, at least those in today's lab. I'll roll them out the morning of for the other labs. And the idea is you have your own subnet, and you can use that information to perform, in this case, just a ping scan. So this is Nmap being run, and this is my own local IP range here, with command line options that are telling it, I forget why it's called SN, but this is saying just do host discovery. Just determine whether or not an IP address is up or not. And then the final part here is output to some sort of standard set of text file output. So ping this IP address range, and this is effectively what you'll be doing in the very beginning of lab number 2. Output the result to a particular file. If we then look at the files in that directory, they're all called ping scan. And if we look at them, they're almost, we can look at that as well. They're almost, directly kind of human readable, and it gives us effectively what we need. So we scanned relatively quickly here. What was that? 16 different IP addresses. Took a few seconds. And in this case, it said it took 15 seconds. It didn't feel that long. And it let you know, based on that default ping scan that it's performing, which of those addresses are up or not. At which point in the lab, you'll get an instruction that looks something like this. See if I have it here in my history. Based on what we have here, and maybe I can make this a little bit larger. And my concern with the labs, as well as what I hope to either have myself or the TAs start to demystify for you, is that when you get a command like this, yes, you can blindly copy paste it and move on to the next part. You can, and you'll get through the labs if you choose to do that. And while we're not necessarily experts in all command line utilities and all sorts of options, and frankly, you get it wrong 5 times, you Google the exact right syntax, and then you get it right the 6th time. That's a very common flow here. Let's walk this through part by part. Maybe this is obvious to you, and that's fine too. What are we doing here? Why is this part of the instructions for lab number 2? It is starting with that same file. If I go back to the prior command here, where I did cat the file, give me the contents of that file, display it. And this was what was output here. So we're starting with that again. Cat that file, display the contents of that file. What does this little character refer to then? There's a pipe. Do you know what a pipe is? Okay. Whether we know from the operating system implementation perspective what exactly that's doing, for now it's basically take the results of this command, treat them as effectively input to the next command. So take cat, that outputs a bunch of text. That was the output of the first command. It's now an input to the second command. I forget what awk stands for. I think it's a set of initials. Process text. It's a very well-known kind of text remapping, text processing command line utility. Any idea what we think it's doing? Yes, $2, and frankly, until you've tried it and played around with a few things, it's not that obvious what exactly it's doing here. But in this case, it basically, by default, can kind of just break this up into column by column, where default a space would act as the column break. Column 1 is host colon, not super useful for us, but that next column here may be the most useful one. Take that value that was output from the cat command, process it through this pipelining engine where it's going to give us the second column of all that text. And then there's still some stuff we don't necessarily want. It just so happens for the output of this particular file that if the line that we're interested in has the word nmap in it, we actually don't want it, right? It's just the extra information. Nmap done at this time or nmap starting at this time. We just want those IP addresses. So grep, which is searching through the output string, and a regular expression to just remove if it has the string nmap appears. We could just nmap, that would work because it's going to find it. And then two kind of carets or greater than signs. That is take the result and directly update a file called ips.txt, concatenate the contents in a file. I actually don't know what's already in that file, so I'm just going to overwrite that file. That's a single caret here. Blow away whatever contents were in that file, update it with whatever the output of this set of commands are. Whenever you have any doubt about series of piped together commands, and sometimes people who do shell scripting stuff like to show off how clever they are, you can always break it down step by step. You didn't have to do all of these things in one step. You could have done them in 1, 2, 3, 4 different steps, and that would have been perfectly fine as well. But my hope for you and my goal for you and my hope that you ask when you come across a command and I didn't explain it, nobody explained it, I hope we're just not blindly following commands here because, really what's the point? There isn't a lot of challenge in copy pasting. You can do it, of course, but having a feel for what you're trying to do, I think will lead to a better outcome than just kind of blindly following instructions. That should be very quick because we're just doing text processing there. We can then look at that file, and now it is the same exact information, and it's just a list of IPs that our previous nmap host discovery has told us that these IP addresses are up. At least they responded to something here. Oh, sure. The answer is you can do almost everything with a combination of a few different commands, awk, sed, grep. That is the answer. It's not a good answer because the honest answer on top of that is it's until you are doing it a lot, there are a ton of options for that particular command. But the answer is almost certainly yes. I have text, I want to process it somehow. You could write some C code or Java code and write a full-fledged application to do all your text processing. You can almost always do exactly what you want to do via that awk command. Like if I only wanted, I'm not going to try to do this live. I'm going to embarrass myself way too much. If I only wanted the .121, .122, .123, and I didn't want all the rest, you absolutely could do that via piping it probably to another awk command, saying I want the period to be the delimiter, and then doing a print 4, and you would get that result back out. But I don't want to do that live because I don't want you to lose respect for me. At least in my experience, that's another kind of manual you have to have open while you're trying to work on how to get the exact right syntax back out. Does that answer your question though? Okay. That was an nmap for host discovery on our own Ice Age machines here. I'm just going to kind of poke at as an example one of our Linux machines in our department. Those are not fair game for taking down, but port scanning them, nmapping them is probably fine. In this case, we passed a few command line arguments here. -A is attempt to do, I don't know if it stands for aggressive, but I think of it as aggressive. Try to do all like the service and port and OS discovery here. T is also kind of an aggressiveness parameter. It's how much time are you willing to tolerate this taking, or do you just want to kind of get it done as quickly as possible? And actually it failed. Host seems down if it is really up, but blocking our ping probes, try PN. Again, you can blindly follow that instruction, but if we were to look at the documentation for -PN, somewhere here in our nmap reference guide, This would be under host discovery still. Under PN, it's saying don't actually try to discover the host at all. Skip it entirely. That can be useful in scenarios in which I know for a fact that machine exists and it's up and running, and it's either blocking pings, as appears to be the case here. The person who runs this machine is 3 doors down. Or I just don't want to alert it via applying some ping pressure first. So I'm telling it to skip the ping and still do service and port discovery here. And just to show what this looks like on a quote unquote real machine in common use, there can be some time associated with that. It is trying a number of different things to attempt to connect various ports. I didn't tell it to limit which ports it's looking at, so it's going to look at a large number of the most commonly occurring and accessible ports out there. And we're going to awkwardly wait while it returns, but it shouldn't take that long. This is just a single machine. Should be no more than about 30 seconds. I'll come back to it. I'm sure it's working. What we do post-ping sweep then is what we just kind of processed. Can we save the output as a list of IPs? And then potentially, should we do a reverse DNS lookup on those? Sometimes we gain additional information from that. If there is a DNS entry, does it have a fully qualified domain name? And does the name itself potentially tell us something about what service or services are running upon the name? If it has www, it's likely a web browser. If it has FW, it might be a firewall. But in general, we save that ping list for additional work later. There's a separate flag that, given an IP list, then can do a reverse DNS lookup. That won't work on our lab Ice Age computers. We don't have DNS running for those, except for one or two small exceptions. Doubling back here to our Linux 4 experiment, I guess I wasn't sure entirely what to expect. We see the host is up, which is good. Port 22 is open, which is SSH, and it's doing fingerprinting. It's giving us an idea of what it believes to be the actual version of SSH. SSH usually comes with some sort of banner, so unless it's a special compiled version that's likely to be correct, has the public keys associated with it, and it also detects an additional port open, which is XRDP. We talked about that last week. That's one of your remote desktop protocols. So this is a computer that gives, at least publicly available via Nmap, 2 different ways to kind of connect to it. You can SSH into it, or you can RDP into it. And so we've learned a little bit more about that particular machine. In terms of trying to do this next step of DNS lookup from IP addresses, we can always just look at via, we can do NS lookup at that point. We can just do an NS lookup on, okay, google.com is fine. And then given, so there's some of our IPv4 and IPv6 IP addresses here. Given one of those IP addresses, we can then do, nmap-sl. This is very well cleverly configured. -sl, which is just do a lookup of it, and it'll tell us what actual domain that comes back up. So Google is running at a scale much bigger than most companies in the world. So you have google.com, and it's actually all sorts of load balancing all across the entire world associated with that. So it's actually connecting to 1e100.net, which I'm sure if we were to look up is some sort of co-location load balancing infrastructure for Google there. When you request a service, you're actually getting one of many different potential load balancing resources. There are then other ping-based host discovery techniques. For the example we used with Linux 4, we just said don't try it at all, but we could have tried some of these other techniques by default. But given those other types of ICMP packets, Nmap, and of course some of these other tools give you the option to check some of those instead of the type 8 echo, echo 8/0, echo request, echo reply, under the assumption that some of those may be blocked and some others may not be. If your firewall set to block all ICMP traffic altogether, then none of these are going to work. But we could play around with Linux 4, for example, in which here we were doing a full scan, but if instead we just want to do um, the the host discovery, and by default, it's basically calling with -PE. That should still fail. It is possible, although I haven't checked it, that for some of these other options, it's working. But in this case, it looks like it's blocking all of our ping traffic here. But there's a possibility that if certain things are blocked, other things are not. By default, if we just try nmap with no command line options, it is trying a few of these techniques already under the hood. There's non-ICMP host discovery. There's actually a lot of different ways to discover whether a host is up or down without using ping itself. As we probably see what's happening on that particular machine, there's a firewall that's blocking all ICMP, all ping requests whatsoever, even from a computer on the same domain. There's other alternatives that, depending on your network architecture, are essentially impossible to prevent someone from attempting. There's an ARP scan. That's a machine that's on the same local network, has to be able to handle address resolution protocol. You have to be able to ask who has this particular IP address, and a machine has to respond, I have it. Or whoever has it, please tell me. Otherwise, you wouldn't be able to actually route packets at all on your system. Can't really be blocked for that reason. If the machines were at all meant to communicate with each other on the same LAN, you wouldn't really be able to block ARP. And of course, there's an option for it in nmap as well. I don't actually know if that would work on this one, but since we're here and we've already tried and failed a few times, I have to think a little bit about where that machine is actually located relative to my machine. We're on the IASD kind of wireless network. They're on the LAN, may not be considered valid for that. Other techniques, really thinking about the concept we talked about before, but the whole point of having a server, having a host, is to respond to some sort of request, right? If it's a machine that's unplugged and just thrown into a closet, yes, you're not going to be able to nmap, you're not going to be able to detect what's running on it, but then the machine's not doing anything anyway. So the idea is that if a machine is available and if it accepts a TCP/IP connection, then it must be listening for something. And that's the other approach that these tools can take to discover whether a host is up or down. We may not be able to easily determine what the machine is running and what particular ports it's listening on, but it must have something that it's listening to. And oftentimes being told that it's not listening to a particular port is sufficient for us to determine whether a host is up or down. So this will be a little bit more on Thursday after our quiz, but I want us to think back to the very basics of our three-way or four-way handshakes for TCP. And we're going to talk about some ways that can be sort of used and or misused to determine host discovery as well as open or closed ports using nmap. To request, we create a packet and set the SYN flag. We wait for a packet with the SYN and ACK flag set, and we sent a third packet with our third way of the three-way handshake saying, yes, we both acknowledge that this connection can happen. Likewise, on the closing side, we send a packet with the FIN flag set. We wait for an ACK, and then there's a handshake that can happen to finally close the connection at the end of a TCP/IP connection. That is how networking is supposed to work. Again, if this is a machine that's not connected to the network at all, none of this is going to work, but the thought is we have a server that is connected for some purpose that is listening to some sort of traffic, and we can use just the fundamental sort of inherent trust built into TCP/IP to be able to determine whether a machine is up or not. Last note I kind of want to leave things on here for today is just a high-level discussion of, to what extent are ping sweeps something we have to worry about? By we, I mean those who are more interested in defending a system here. There isn't a clear consensus on that answer, other than to recognize that historically there have been certain attacks that made use of ICMP. I have the link there. I'm not going to actually go into it right now for that first one. But if we were to go back to, let me just zoom back real quickly, what our ICMP header and data can look like, it's kind of a funny protocol in a sense, in that you have your header information for the ICMP, you have the different types and codes, and you have a checksum associated with it, and then you have this variable length data, but there really isn't a lot of data one needs to send over that ping. It's really just things like, up or down or particular flags or timestamp information and things like that. Yet the standard, the spec itself allows for quite a bit of data to actually be sent over those pings. So in terms of some of the disadvantages of using ping, there was all sorts of kind of fun initial attempts to use ping as essentially a covert channel. That if I had two servers, a server and a client, and all sorts of other communication channels were blocked, but ping was left open, you could actually have a covert channel there. You could leak information, you could send data fairly reliably just by using that data field in the ICMP packet. Similarly, it turns out all sorts of systems weren't especially robust to sort of malformed pings. Either just a very large number of them, essentially maliciously created, or very large individual pings. And that's both, they're a little different, but those are both referred to as ping of death, where historically that was very much the case, that you could take down systems just by overwhelming their ping handling subsystem of the rest of their network infrastructure. And by default, I think most firewalls now prevent those type of attacks. So I say it's not necessarily a closed issue whether or not one should block ping traffic or not. There's a website specifically trying to make one case or the other. The conclusions of that particular resource, which is not necessarily definitive, that it's still a very useful service. And the trade-off that that recommendation makes is internally, it still makes sense to have ICMP up and available and running. And you can block it in terms of blocking it from external traffic, but allowing it for internal traffic. You keep it internally so you can keep track of your own network infrastructure. You use it still as a monitoring utility to determine what of your hosts may not be acting appropriately, which ones may actually be down, to determine potentially the path that particular traffic may take in your underlying network, but then maybe block everything that's happening externally. Because when it's someone like us, someone like me attempting to apply those pings, it's very common that it's not being used for good purposes. Let's actually leave things here for today, but there's another kind of obscure looking command that's on this slide. And between now and Thursday, I want you to take a look at that. And similar to what we just did with our awk and other commands, I want your own attempt, just for your own research, to attempt to demystify what that particular command is attempting to do. It's not super duper advanced, but it's just another one of those examples that I want us to get a better feel for, to understand what this is actually doing, so it's not just a magic command we're emitting here. But let's leave things here for today. Get started on your lab 2 this week, and we have our quiz on Thursday. And otherwise, I'll see everyone then.